Live.
Hello, guys. So here we are once again. We have here Graeme Rocher that will speak about what's new in Micronaut 3.0. He's an architect at Oracle Labs. Before passing the word to Graeme, let me just say that this is the final talk from this morning. In the afternoon, we'll have the workshops, but this is the last talk that we will have this morning. So we'll have time to have lunch after all and to get into the workshop in the afternoon. But first, let's hear this awesome talk from Graeme. Graeme, are you ready to teach us a little bit about Micronaut?
Really looking forward to it. Thanks, Luis.
So go ahead. Thank you.
Great. Thanks, everybody, and welcome to the session on what's new in Micronaut 3. The intro's already been done, more or less, so we can probably skip any intros for myself. But in terms of Micronaut, for those of you who haven't heard of it, it is a relatively new framework focused on modern architectures like serverless and microservices. However, it's also a complete application framework for really any type of application. It just happens to be that the focus is on those areas. If your application has a static void main, then you can use Micronaut for things like dependency injection and so forth. So the basis of it is a dependency injection container, much like Spring or CDI. Except that it works very differently by hooking into the Java compilation process and computing everything at compilation time. It also features a HTTP client and server based on Netty, but all of that is completely pluggable. So we have different server implementations for things like Tomcat and Jetty and gRPC applications, and the actual server part of Micronaut is can be changed. You can find out more about Micronaut at micronaut.io and do start the repository on GitHub. It's at Micronaut project/Micronaut core, and follow us and keep track of it. Micronaut has a very close relationship with GraalVM. GraalVM is a technology out of Oracle Labs, which is where I work, and it features an ability to plug into the regular Java virtual machine in JIT mode and replace the JIT, which can improve your application's throughput between 28 and 30% and reduce latency. Most people are probably familiar with GraalVM nowadays for its ability to compile applications into self-contained native binaries or native images. This is a really cool feature of GraalVM, and it's great for cloud deployments, serverless, CLI apps, low memory footprint microservices, IoT. And it's really enabling Java applications to go places that weren't really feasible or viable before. In addition to that, GraalVM has has a truffle language framework, which allows you to seamlessly interoperate different languages. You can find out more about GraalVM at graalvm.org and check out the demos on GitHub. So like I said, Micronaut and GraalVM have a close relationship. And the reason for that is the way Micronaut works. Micronaut at compilation time eliminates the use of reflection, runtime generated proxies, bytecode generation, and dynamic class loading by analyzing your application at build time and producing essentially an application that it doesn't use any of those features. Now, GraalVM supports all of these features, but you have to pass in additional configuration to enable them, to enable the use of reflection or runtime generated proxies or bytecode generation or dynamic class loading and so forth. Whilst with Micronaut, none of that configuration really needs to be fed in. So the native image tool has a much easier job in terms of converting the application into a native executable. And once you do so, your Java application's startup time is dramatically reduced. A Micronaut application compiled with native image starts up in like 20 milliseconds. and memory consumption drops significantly. So they make a great pair for building low memory footprint microservices, command line apps, serverless applications, and a range of different use cases. Micronaut and GraalVM can be combined. So let's talk about Micronaut 3 now. So Micronaut 3 came out a few months ago, like 2-3 months ago. And we had a number of themes that we wanted to address with Micronaut 3. So JDK 17 support was a high priority. Bringing Micronaut support to all of the different features of JDK 17. Support for GraalVM 21.2 and 21.3. Which introduced support in turn for JDK 17 and native image for those stacks. And in addition, we've started to transition Micronaut away from the JavaX namespace, towards the Jakarta namespace. So Micronaut's dependency injection layer is based on JSR 330 inject annotations. We have moved over to the equivalent Jakarta equivalents. In addition, we had a strong focus on reactive with Micronaut 3. So in that, we wanted to support a range of different reactive libraries. So Micronaut 2 was really, primarily coupled to RxJava 2. And with Micronaut 3, what we have is decoupled it so that you can swap in really easily Reactor or RxJava 3 or RxJava 2 or whichever reactive library you want to use that you want to use with Micronaut. And in addition to that, with Micronaut data improving a lot, we have support for R2dbc for building reactive applications. And in addition, one final aspect of Micronaut 3 is many different improvements to dependency injection. So we are gradually moving toward Micronaut towards one day supporting a revision of the CDI specification called CDI Lite. And so many different features were added to Micronaut 3 to support it becoming a CDI implementation at some point in the future with the build time profile. In addition to that, more recently we released Micronaut 3.1, which is the first minor release of Micronaut 3. So, and there was a few nice little goodies in that one, including support for Kotlin coroutines for Micronaut data in for our Kotlin user base. We added a new version of the Kubernetes integration that lets you integrate really nicely with the Informer API from Kubernetes and K8's events. So you can easily listen to K8's events and respond to them in your Kubernetes infrastructure. The Oracle Coherence integration was also released in final form, brought out a preview, and there were lots of little minor improvements to 3.1. And just an update, Micronaut 3.2 is in fact due to be released next week, which will again bring incremental improvements to the Micronaut 3 line as we keep going. Okay, so I'm going to start demoing some Micronaut 3. For those of you who have attended my presentations, they tend to be very interactive and demo heavy. So the best way to show new technology is to demo it. So I have my IDE over here, and I'm going to create a new project with Micronaut 3.1.4, which is the latest version. I'm going to choose a Micronaut application. We're going to use GraalVM and Java 17. We'll just call it demo. Use Java, and I'm going to use add data R2dbc for the moment to enable access to Micronaut data. We can use Gradle for the build for the moment, or you could choose Maven if you want. We'll choose JUnit and we will create a new application here. So dev Micronaut demos Porto, create it over here. Create the application, trust it, and I have my application imported into my IDE. So for those of you who are not familiar with Visual Studio Code, I'm using the Visual Studio Code for this demo. Micronaut has great integration in IntelliJ as well, if you prefer IntelliJ IDEA. I'm using VS Code with the GraalVM extension pack installed. So GraalVM tools for Java and GraalVM tools for Micronaut, both of which provide a really nice integration with Micronaut and allow you to build applications. So here we have a Micronaut 3 application. We wanted to make sure that it was an easy upgrade from Micronaut 2, so not a huge amount has changed really. Like I said, we have it's just a standard Java app. If you haven't used Micronaut before, there's an entry point where you can start your application, which, there's a main method which basically starts up the app. And from here is where you can start building your app. And Micronaut has a strong focus on testing. So when you create your application, you automatically get a test, which uses Micronaut Test. Micronaut Test is a testing framework which has extensions for both JUnit 5 and Spock. And it lets you annotate a JUnit 5 test. And with that, you can then dependency inject components into your test and assert and write integration tests. And in this case, it's just asserting that the application is up and running. So you can run this test directly from your IDE, like I can do here, and you're up and running. So, one of the big things about Micronaut is how fast it is to write integration tests. Like this is a full integration test that starts the whole server, and it executes extremely quickly. For development time, if you want to access the server in a browser, you can run it from here, which will start up the application, and you can then open up in a browser. I don't actually have any endpoints in it, so it's just a 404 for the moment. But basically, you can access it directly here. We also have integration with continuous mode, so you can start the app, for example, and then as you make changes to the app, it will automatically restart the server and so on and so forth. Okay, so let's talk about some of the features in Micronaut 3 first of all. So like I said, one of the strong focuses with Micronaut 3 was support for Java 17 and the features in there. So for example, I can do things like new from template Java and create a record, and maybe we can call it engine or something like that. And this is a Java 17 record, and you can, maybe it has a name and maybe the number of cylinders it has, and so on. And so two record components, the name and the number of cylinders. And so some of the things that we can do immediately is use this record in, for example, JSON responses and so on and so. So, for example, if I were to create a new class here, maybe let's call it engine controller, just for fun. And what I can do is list all the engines in the system and add a GET request that basically lists all of the available engines. And add an import for that, and then return list of, and what we can do is use new engine V8 with 8 cylinders, and another V6 6 cylinders or something like that. And now we have 2 engines. So what we have done here is exposed a engines endpoint that returns the engines, and that is exposing a list of 2 engines, V8 and V6. So I can really easily write a client for this in Micronaut 3. So for example, I can come in here and say, write an engine client that maps to that same endpoint. Let's call it engines, and returns a list of all the available engines from my client, like so. And I can inject this client into my test method, like so, and list all the engines in my system, like so, and assign that to a local variable, for example. Results, and maybe add an assertion here, so equals to results dot size, etc. You can replace this with a static import if we want, and run this test. And it's failed because okay, let's do it. So one of the things I did was I forgot to put that this is going to send a GET request. So we actually need to annotate which what kind of request the method is sending. Otherwise, it will present me a failure. So let's run that again, and now the test is passing. Now, one of the things you'll notice is this is just a raw record. So in this case, we're actually just relying on Micronaut's integration with Jackson. However, we can also integrate with Micronaut's bean introspections, and there's a number of advantages to doing that. So what you can do is you can add @introspected to this record. And what that's going to do is allow Micronaut to essentially instantiate and read record components dynamically, and also basically dynamically instantiate and dynamically use copy constructor approaches to return new values. And it will also plug into Jackson such that we can serialize and deserialize this engine component to and from JSON without using reflection. So we've integrated directly with records in JDK 17. And the other thing that you can really do, which is really nice, is, for example, you can apply, when you add introspected to a record, you can apply validation constraints to it. For example, you can say this shouldn't be blank, and this should be a positive number, for example, and apply different validation constraints directly to my record component. So if I were to, extract some of this out, and let's exercise some of the dependency injection features of Micronaut, for example, say I created a new interface here, or new class, let's call it engine service. And I didn't want to have all my logic directly embedded into my controller here. So I'm going to actually copy this over here for the moment. I'm going to make this a singleton. And when I add singleton to a class in Micronaut, and singleton is from the Jakarta inject namespace. So here we're seeing some of the Micronaut 3 features surfacing. where I'm using essentially a Jakarta.inject definition here instead of JavaX.inject. So we've moved to the Jakarta namespace. And what I can do is add, for example, instead of this being a kind of hard-coded list in there, I'm going to have a list of engines. And we're going to say this is a new array list, for example, for the moment. Like that, and we can import this. And whoops, yeah, let's move to a constructor for the moment, and move all of this here. So add all these guys to that constructor and return my engines from here. And then what you can do is you can add, like, for example, a save method, save new engine. And you can do engines.add engine to add it. Now, what we can do with Micronaut's integrated support for validation is you can add an annotation here saying that this should be valid, right? And by adding add valid here, I'm only able to save valid engines. And because I've got validation constraints actually on my engine instance here, we can catch those kind of errors early with direct integration with records and validation. So let's write a test to that to make sure that it's my test save, for example, test save valid engine. So we're going to inject my engine service in here, and we're going to call engine service save new engine. And let's, for example, violate some of those constraints and see what happens when I run this test. So let's run this new test and see what happens. So I think probably what I need to do is add validated to this. There we go. So I forgot the validated animation. So you actually have to declare that a particular service is validated with @validated, and then it will ensure everything is validated on the service. So I added @validated to my service. And now you can see that we get a constraint violation and exception for my record because I'm passing in an invalid value here into my engine service that I've created. So it's really that easy to integrate with records and use them within your Micronaut code base as these kind of value classes. Now, the other really cool thing we can do with records, Java 17 records, is to essentially make them into entities that are mapped to the underlying database. So for example, I can actually, instead of making this introspected, I can actually annotate this with @mapped entity to use Micronaut data and map it to a database table. So just by convention, this is going to map to an engine table. And if I wanted to, I could use JPA annotations here. Everything I'm doing here is with Micronaut data JDBC, which has support for records directly because it's a simple data mapper. There's also Micronaut data JPA, but the JPA model doesn't really support because it's stateful and uses lazy loading and has concepts that require kind of set arithmetic and so forth, like dirty checking. It's not really a great fit for using records as entities, but Micronaut data JDBC, because it's a simple data mapper, is. So And we can even model things like the ID. So for example, I can add an ID of a book in here, and I can make this a generated value from the database that is nullable, for example. And then I can come in here and I've kind of broken a whole bunch of stuff, but I can create a new interface that is a engine repository. Oops, I need an interface that is a engine repository like so. And I can make this a @JDBC repository with a dialect of H2, which is, I'm just using the H2 in-memory database for the moment. And I can extend from CRUD repository, which is part of Micronaut data, and I can pass in my engine type record and the type of ID. And what CRUD repository is going to do is it's going to get me some CRUD operations that I can perform when my perform create, read, update, delete operations to the database. Now I can come over to my engine service here, and instead of using a list of just like in-memory objects, which is like not very realistic in terms of like real application development, I can instead use dependency injection here to inject the engine repository into my engine service and create a constructor for it. And basically what we can do is remove this. Well, what I'm going to do is just take this out for the moment. We're going to need that. So what I'm going to do is I'm going to add a new post. Let's do a event listener that runs on startup. So we're going to add an event listener to my app that basically takes a startup event, and we can import that, and we can make this event listener transactional so that it runs when my application starts up. And what we're going to do is we're going to do repository dot save all and those engines, so that basically it starts up, and we can feed in null for the ID as the initial value, so that there's no IDs assigned. Then down here we can use, instead of this kind of hard-coded logic, we can use my repository, my underlying repository, to save new engines to the database, for example, or I use the repository to find all records. And find all actually returns a iterable from CRUD repository, but it is possible in Micronaut data to override methods. So I can actually override the find all method by doing override implement method find all and override that, and I can override it to return a list instead. And Micronaut data will implement that method for me against the database, coercing the correct type. So then I can, now my engine service is compiling fine. So now I can come into my engine controller here and inject my engine service into my using constructor injection into my controller, and instead return a list of engines from my engine controller. And hopefully at this point, my test here that's using the client is going to work in terms of interacting with the database. So let's have a look. Let's run the test and see what happens. the test passes. So my application is actually now a full database application where I'm using records that are mapped to underlying database tables, and I'm using dependency injection to interact with those, and basically using records extensively throughout my application, and of course using the Jakarta namespace for dependency injection, which is part of Micronaut 3. Now, and all of this is integrated with validation and everything, with regards to being able to validate records and so forth. So yeah, let's see what else we got. So the other thing that we have extensive support for in Micronaut 3 is reactive. So everything that we've done so far in Micronaut is essentially been blocking operations. So we're interacting in a blocking manner with this repository, and everything is essentially using synchronous operations with JDBC. However, there is we do, as part of Micronaut 3, have extensive support for reactor and reactive programming in general. And what you can do is you can, instead of using Micronaut data JDBC, you can use data R2dbc, right? And R2dbc is a reactive implementation of Micronaut. And what I've done here is I've dropped into terminal to use feature diff in Micronaut, which is of the command line, which allows you to have a look at what it takes to add a feature to Micronaut, for example, R2dbc integration. So I can type mn feature diff and pass in features data R2dbc, and basically I can activate, I can see what I need to do to my app to add R2dbc support. So as you can see, under config, under my application configuration here, I need to actually enable R2dbc support here. There's a column selection mode in this, but basically you have to configure R2dbc as a data source, and you can use the same data source for both the reactive and non-reactive connection if you want. And then you need to add a few additional dependencies. So I need a dependency on Micronaut data R2dbc in my build config here, and also a runtime dependency on the H2 R2dbc driver. And with those two things, I've now added reactive to my application, and with that change, you can actually start using reactive programming and completely non-blocking integration. And the only difference is that I have to do is essentially, instead of extending CRUD repository, there are reactive variants of the same thing. So instead of CRUD repository, I extend reactor repository. And we also have, RX Java CRUD repository and different implementations, but basically you can extend different superclasses. And then the other thing I have to change is to change this to be a R2dbc repository with the appropriate dialect again. And now it should be a fully reactive implementation. And so you'll see that instead of returning a list, we are going to return here a reactive flux, for example. And when you call things like save all and so forth, you actually have to block in order to actually perform the operation in a kind of like, basically with reactive, when you call things like save all, this is actually going to return a flux itself as a return type, which doesn't actually execute at that point. So you have to actually block until, or collect them all, click this, then unblock, to actually execute that operation if you're trying to use reactive in a kind of synchronous way. With that in place, we can also return a flux from my controller. And now I've turned this this application into a completely non-blocking interaction with the database, where it's going off and listing all my records, returning a flux, and in a completely non-blocking manner, right? So the only blocking part is the startup, when the application actually starts up saving to the database, right? The actual interaction with the database in the controller is doing so in a non-blocking manner. Now let's see if this actually works, and I haven't fluffed something up demo-wise, which is highly likely with these things. Which I haven't. So, and by the way, if this is running a full integration test, and we can actually verify that by going into my logging configuration, where I can say io.micronaut http.client level equals trace. And if I come back to my application here and I run it again, and then look at my debug console, you can actually see the data coming back with database IDs assigned, and it's all working as I anticipated it would. So in a very short amount of time, hopefully that demonstrates a whole bunch of features. And the other thing that is, of course, important. Now, in general, when you work with GraalVM and native image, Micronaut will deal with all the kind of reflection that you may need in your application. But if you do need reflection, I want to point out you can add reflective access to any type. So if you ever get like a class not found exception when using GraalVM or anything like that with Micronaut, remember that you can enable reflective access on any component just by adding reflective access, and it will work. But basically, with GraalVM, you can essentially build this into a native image. So I can do that directly from VS Code with build native image, but you can also do it from terminal. So if I do Gradle W native image, and if I had chosen Maven, I think it would be Maven W package / d packaging equals native image, like so. But I can essentially build this into a native image, and the native version of the application will be significantly smaller and lighter and start up a lot quicker. So this is actually going to generate the native image. So the generation of the native image takes a little bit of time, and this is one of the trade-offs with AOT. So I'm going to let it running for a little while and finish up the rest of my presentation so that we can come back to it and hopefully have time for Q&A. But with Micronaut 3 and GraalVM, we've achieved greater efficiency with native image. So we have a new build time format, metadata format with Micronaut 3, which is able to reduce memory consumption 20%. We've also reduced startup time, and the overall native image size is significantly smaller as well. And we're working on a lot more optimizations. So we're actually working on a really exciting optimization that provides a 3x boost in startup time. And we're working on a number of different fronts to make Micronaut smaller and more efficient for native image, working closely with the GraalVM team on this. So native image is a strong focus, and building native applications is a strong focus of Micronaut. To get started with any of these technologies, GraalVM 21.3 is JDK 17 ready, and that's what I used in the demos. You can generate a Micronaut application that's ready for JDK 17, open it in your favorite IDE, and head over to grab the documentation on Micronaut or GraalVM or JDK 17 and just start developing. They provide a great experience, these tools. The developer experience is awesome. As you saw me, I was developing a whole app in this talk, and it was a lot of fun. And do check it out. So let's switch back. It's nearly finished building that native image, so it's going to take a little bit longer. So in terms of some new resources here, you can find out everything that's new in Micronaut 3 in the What's New guide, and information on upgrading. Now, the upgrading experience is really interesting with Micronaut 3 because we have if you go to docs.micronaut.io user guide and you head over to upgrading, we actually have some integration with Open Rewrite. So if you're upgrading from a Micronaut 2 app, we will actually propose changes to your app, and it makes the upgrade a whole bunch easier. So it's generally an easy upgrade, but there's some automation in place to help you upgrade as well. So do check that out. That was part of what we built with Micronaut 3. Yeah, so that looks like it's finished building the native image. So we can run that, and you can see that when we start up the app, even though this is like, you can see more or less the startup time is 39 milliseconds, even though this is like teaching database interaction and all sorts of things. And the other thing is the memory consumption of this app. So this is my running app here, and you can see that the memory consumption is like 20 megabyte for this Micronaut application. So pretty impressive with native image. So in summary then, Micronaut 3 optimizes an already heavily optimized framework, especially for GraalVM. We delivered standards alignment with Jakarta, the integration with JDK 17 and things like record, and a huge leap forward for Micronaut data with support for R2dbc, records, and all sorts of things. So, and I hope you enjoyed this presentation, and we now have time for Q&A. I hope.
Thank you very much, Graeme.
No problem. Are there any questions?
One question will be, what are the benefits that you see using this approach?
You mean going native or in general?
In general, yeah.
So, the massive benefits, first of all, let's talk about Micronaut. So Micronaut eliminates, like I mentioned, reflection, runtime use of proxies, runtime bytecode generation, dynamic class loading, and all of that leads to like a much smaller application, right? So regardless of native image, it leads to like when you build a Micronaut app into a jar file, it's like 10 megabyte jar file, and the lack of reflection reduces memory consumption, improves performance, makes stack traces shorter, easier to debug, and we can catch a lot of errors at compilation time, right? A lot of interactions with Micronaut are compilation time checked. And then when you look at native image, there are obviously trade-offs. When you build a native image, you lose write once, run anywhere, and the build times are longer. It takes a couple of minutes to build a native image of that application that I demonstrated. But the trade-off is that you get a much smaller application, which you can take places where maybe Java couldn't go before. For example, you can deploy Micronaut to a serverless platform like Oracle Function or AWS Lambda, and stay within the 128 megabyte memory limits for the smallest sizes. You can deploy Micronaut to IoT devices and Raspberry Pis and things that require high, smaller resource, and that have smaller resource requirements essentially, which was not technically possible before. So, there's lots of advantages in terms of being able to continue to use Java, which is the fantastic language, but take it places where it wasn't possible, right?
Thank you very much, Graeme. It was really nice to hear. There were some people writing that it was the first time they were listening to this subject. So thank you very much for giving this introduction to this team, because I'm pretty sure that for a lot of people, this was the first time they were listening to Micronaut 3.0. Graeme,
awesome.
Thank you very much. We'll keep you in touch. For the rest of you guys that are still there, please have a lunch, take a rest, and we will be here at 2 for the 2 workshops that we have. They will be practical, they will be interactive. So bring your best energy and we will wait for you here. Thank you very much. See you in the afternoon.
Thank you. Thanks.